Hello, my name is Robert Blunt, and I'm here to present the practical application of using unmanned aerial vehicles for bridge inspections. I work for a company called VHB. We're approximately 1,600 passionate professionals, founded in 1979. We have 30 locations up and down the East Coast. I'm in our northernmost office up here in Augusta, Maine. Not knowing the audience, I figured I'd take you through some quick highlights for the U.S. bridge inspection programs. The inspection cycle for bridges is every 24 months, and we do this to national bridge inspection standards, where we do element level inspection, we code the elements, and then we quantify them into condition states. This coding guides the framework for the reporting. This is reported annually to the Federal Highway Administration and becomes part of the National Bridge Inventory. The coding is similar to here. This is something we use as a guide, and we generally keep the bridges in the good to satisfactory and very good condition. And planning starts to begin in the satisfactory and fair conditions when some of the elements of the structure are falling into these categories. There's many types of bridge inspections that you might not be aware of. We do routine inspections, fracture critical inspections, in-depth or hands-on, such as pin and link inspections, where we actually do some non-destructive testing to test the integrity of the pins, underwater inspections, and specialty damage inspections in an emergency, flooding, or natural disasters, and vehicle impact. So traditional bridge inspections are what I call routine inspections. This is the bread and butter of most inspections that we do, where we'll walk over the bridge and visually look for deficiencies. We can hammer sound and scrape paint and take a look at things sort of hands-on with what we can reach just from the ground. We'll also walk under the bridges. Sometimes when conditions are correct, we'll put on waders and go underneath the bridge and check for scour and look for other deficiencies under the structure. We'll sometimes get onto a ladder and go up and look at the bearings during routine inspections. Here we're using a boat to go under the bridge. The water was too dangerous to wade, so we had decided to use a boat. Here's another type of unique access. This is a man lift on a barge, power barge, in fairly decent current. Pretty tough type of access. On movable structures, it'll be a multidiscipline team. We'll do a combination of boating and a little bit of climbing. Here's our common practice, is to use an under-bridge inspection truck, where we'll close a lane down and inspectors will be in the bucket and will go down underneath the bridge to get a hands-on close-up view of the structure. Sometimes we'll need to free climb if there's something obstructing our U-bit operations. Diving inspections when conditions warrant. And some specialty inspections with, this is confined space entry up in Acadia National Park, some confined space entry that we did in one of their structures. Something we decided to try out a few years ago was get a pickup truck and a couple of guys willing to fly a drone on some bridge inspections. So we have a 107 licensed pilot and a bridge inspection /team leader, and equipment to view while the UAV is in the air. So I call this the will it work phase. We were going to try this out. We went to DOT and said, hey, can we try this? And thankfully, client said, yeah, give it a shot. Make sure the camera can look up at the underside of our decks and give it a go. Here's a video of our first flight. This is the Max Wilder Bridge. Here we were teamed with Airshark and Media Wing for our first flights, and we were also performing pin and link inspections, or pin inspections at this time, but we were experimenting with the UAVs. We had a spotter on the point to look out for boating traffic. We utilized a DJI Matrice 100 with a 30 times optical zoom camera mounted to the top. and achieved very good results with the high resolution camera. Really relying, our standoff was quite far from the bridge, and we really relied on that zoom capability to capture some really good images of the underside of the deck. This was a complex structure to fly, but we got the job done, and the team learned a lot. Here's the live footage as the drone's in flight. I can see what the drone is seeing. And again, some results of that first flight. What a great place to fly and an experiment for the day. Thank you, DOT. So here's another one of our early bridges that we flew down downtown Augusta Memorial Bridge, and we achieved really good image quality here as well. And here was, I think, the third flight we did, maybe the fourth. This is Taconic Bridge between Waterville and Winslow, Maine. The bridge here is over the Kennebec River, and you can see the dam kind of comes underneath it. We had performed a hands-on inspection of the structure earlier in the summer, and then our charge here was to utilize the UAVs. The U-bit, unfortunately, on the upstream side, could not reach the downstream side trolley, so we needed to find a new way to get to that trolley arch and get some good images. The U-bit could not be used on the downstream side because of the planters and the sidewalk width and the load rating capabilities of the trolley arch. Here's again some footage. We're on river left here taking off. That was one of our locations for takeoff and flight. Not a good place to put a boat or being a set of waders. And here we're set up on river right or left of your screen. You'll see the UAV team positioned for the flight, for line of sight the entire time. We got permission from Brookfield, thankfully, to have access to the top of the dam there, and real good vantage point for these drone flights. The crux of this job was looking at, if you see in this image, the right-hand side is a built-up riveted plate girder, the left is the trolley arch, and right up inside here, a real tough place to look and really dark. So that was really the challenge of the day, is I wanted to get that upward-facing camera to look up in these dark places and see what we could see for the department. As you can see, we really got up tight into this structure, and we were able to see right up inside that area dark. Here you can see the trolley arch, the arch fascia. And the crew packing up for the day. Here's again some of those high quality images we achieved. We did video and still footage on this structure. And here's that dark area. A little bit of post-processing of some of these images to achieve this photo quality. So here's the trolley arch and the fascia of the structure and that overhang that we were concerned about. And really getting up close and personal in those darker areas. Like I said, a little bit of post-processing of the images after we came down, but I think we achieved really good results. So we had really good success, and VHB as a company, we've been doing a few flights per year with our UAS team, and currently we have 20 certified bridge inspectors on staff, or team leaders. We have 8 certified pilots and 9 operational aircraft. Not all these aircraft are used for bridge inspection, and not all these drone operators fly bridges, but this gives you a sense of how active we are in this realm of UAS. Every once in a while, some of the more difficult flights are the bridge inspections. So what we've found, UAVs can cut costs and seem to be safer than other access methods that I outlined earlier in the presentation. It often eliminates traffic control and easier to access some of these very difficult locations. We can capture high quality photos and video. We can scan the entire structure and can locate bridge elements that may need a closer hands-on inspection. In an emergency, this may be the only safe tool. What we found is this is probably going to be a standard tool in the inspector's toolbox, and we're actively using it to enhance all the inspection work we do for the department. Some of the challenges along the way, this flying in a GPS-denied environment, very close to the water, in varying flight conditions, takes a real inspection team and communication between the team inspector and the pilot. These platforms can be very expensive, and you're flying through fixed objects. So, we have lost UAVs due to wind gusts and such, but sometimes it's worth the cost to get some of those great images. We found the environmental conditions, we really got to plan the day and have the right day. We've flown in snow, sleet, and freezing rain. Don't recommend the sleet and freezing rain, but that would just had to get the job done. This is not a tactical technique. We're never going to replace the human with hammer sounding and scraping. I don't see it just yet. And the data acquisition and retention is very challenging. We've found that, you've got great high definition images and video, but that also takes up a lot of space. So we find ourselves sometimes reducing the file sizes to put into InspecTech, but we do keep the raw images. So here's one of our inspection drones with a top-mounted camera gimbal. And here's a unique setup that we sometimes utilize. Here the pilot is controlling the UAV, and I'm actually in control of the gimbal for the camera. And so the UAV pilot makes sure we don't hit anything, and we're having a safe flight, and I'm achieving the photos that I'd like to achieve to get a very usable inspection. Here's another thing that we've done. We can live feed during the flight, and this is projecting onto a 27-inch monitor out in the field. Apologize for the photo quality here, but the image on the screen was really handy to have and to be able to look at the images with the client side by side while in flight. So here's an example of one of the bridges that we've flown. This is Keyser Falls Bridge in Keyser Falls, Maine. You can see here on the right-hand side of the screen, the dam comes under one of the spans, and then there's a slight river torrent underneath the rest of the bridge. Not a great spot to wade or bring a boat. The bridge is probably 4.5 to 5 feet above the water, just above the dam, and not a real safe place for a boat, and certainly not my boat. And here we were able to extract video stills captured from the drone just underneath that span with about 4, maybe 5 feet of clearance. Real tough spot to fly, but we were able to capture some decent images down there, and definitely high quality video would show up better than a screen capture from the video. But the inspector is able to review the video and post-process. Here's some of those high quality images from down underneath the structure. And here's the South Channel Bridge. So this channel is actually the intake for the power generation. Here, to capture an image like this, you'd have to shut down the power generation, lower the impoundment, and then use a U-bit or a boat down underneath this structure. But we're able to fly down there and get some good quality images as part of supplementing our inspection. Here's the Margaret Chase Smith Bridge. We did the North Channel and the South Channel. This bridge here, the South Channel, is just upstream of the intake for a power station and the dam. So it's in the impoundment. And there again, not very far off the water, maybe 5 or 6 feet. The charge here was to look for deterioration that they might not have been able to see during normal routine inspections and not interrupting power generation or traffic with a U-bit. So we noted some deficiencies in some concrete spalling, probably from the haunches underneath at the deck ends that they were able to plan for in their development of their capital program. Here's the North Channel Bridge. This bridge here presented some unique challenges for us for the first time. If you look on the left-hand side of the screen, there's a rope swing for the kids here, and a great spot to go swimming. And then during flight, The pilot turns to me and says, I think there's some fishing line down there. So this is apparently a great spot to go fishing as well. So there was a lot of fishing line hanging from this bridge, which created some unique challenges for rotary aircraft. So General Sullivan Bridge, here's this unique barge with man lift on it. Really unique access, but not the easiest thing to operate. And here's some of the footage that we captured with the drone up in some of those same tight areas. This bridge is no longer open to traffic. It's going to be under design for rehabilitation for pedestrian traffic only in the near future. On the left-hand side, you can see a perforation. I believe the drone's going to pan to the left, and we'll see those perforations. But we're right up inside the truss, getting some real high-quality video, and really be able to make an assessment of that floor beam. So here's again some of those high-quality images. You can see those perforations in some of the members. And here again, just another example of high-definition images. And if you notice, what I'd like you to be noticing is the beginning of the presentation, the image quality was really good on our first few flights, but really the cameras have increased in quality, and we're getting very, very good images as compared to some of the early days when we were flying. So some of the other things we're doing, what I say next level and other, it's kind of a potpourri of other things that we're trying out and doing. We've done a little bit of experimenting, sort of another show me is the thermal. So here, the blue is just a tracing of what the resident engineer had sounded out for the deck repairs. And then we were able to fly this in August and superimpose that imagery on top of the infrared imagery and really see, if things correlated pretty well. And this takes a ton of post-processing time. And here's sort of a proof of concept. I want you to pay attention to the right-hand side of the screen. You can see the white sound, the outline from the resident engineer, and then the infrared technology. You can actually see there's a very good correlation on the right-hand side between what the resident sounded and what the infrared picked up. So sort of that proof of concept, we could have convinced ourselves it's a good tool, and we're now using it on other projects that we're working on. We're doing rehabilitation. We still do sounding, but we also use infrared, and we fly the bridges to make some better, what I would say, informed decisions about the rehabilitation quantities. Here's the Sagnahawk Bridge in Bath, Maine. This is on Route 1. A lot of people like to come to Maine in the summertime, and this is one of the major arterials. Not a great place to interrupt traffic in the summer. So we wanted to take a close look at the bearings as part of some of the research that we were doing for Federal Highway. So we utilized our drone, and we were able to get right up there and look at those bearings and not interrupt traffic on Route 1 in Maine. And would also need confined space entry to get onto the scaffolding that you see in the background of this image. So we were able to see the bearings and kind of monitor everything right from shore. We've also been lucky enough to be involved with Federal Highway Administration, Maine DOT, and Maine Turnpike, and University of Maine for some controlled environment testing. Here we took our drones in a lab in a controlled environment where it's a GPS denied environment. So the building blocks out the GPS signal. And then what you have here at the University of Maine is a W2 wind and wave basin. Basically a 12 to 15 foot diameter wind machine over a wave pool. So really simulates a bridge condition pretty well. We didn't have a bridge component hanging over the wave pool, but we did have some images and some cracked concrete. And what we would do is we would modify the lighting and the standoff distance of the drones, and then we would see how they performed under different wind conditions. So, how fast and how much low light, and really just pushing the limits of the drones and the operators in this controlled environment. We did this for I think it was 3 days of work, and that report should be coming out soon. Here we're just monitoring. We can see we're varying the lighting conditions, observing the drone. Is it tracking? Is it not tracking? And really had an amazing time at the university testing out our various units and platforms. We also use our UAVs for construction documentation, periodically taking aerial images of the job site and monitoring the progress of the jobs. I'd like to thank Maine DOT, the University of Maine, Maine Turnpike Authority, Turner Fairbanks Highway Research Center, and Airshark and Media Wing, and specifically Maine DOT and VHB. Had this idea a long time ago to give it a shot, and we're seeing some real good results, and it's been fun to be involved in this over the last few years. So if you have any questions, feel free to reach out. My contact information is right there, and I look forward to talking to you at the open panel discussion. Thanks so much.